Alrighty, welcome to lesson 2.7, which is the last lesson in this unit. And now, what you've all been waiting for, we are talking about circles. We're talking about the area of circles. So, what I'm going to get you to do, first of all, is I'm going to get you to pause my video, and I'm going to get you to watch this one. I'm going to put the link in the description, and I'm going to try to link it in the video. But pause it, watch it, and then we'll move on. So, assuming that you've watched that video, which you have, you learned that the area of the circle has the formula pi times the radius squared. And remember, squaring is the same thing as timesing it by itself. So that could be the same as pi times r times r. If you're ever with a calculator that doesn't have a square button. Right? So let's do some examples using this. First thing, the diameter of a circular steel maintenance hole cover is 24 inches. What is its area in square feet? Alright, so first thing, what you got to do is you got to convert this into square feet. Into feet. That's what I'm going to do. So I'm going to do that up here, just to save some space. So I've got 24 inches, and there's 12 inches in a foot, so that'll give me 2 feet. Wham bam, there we go. Alrighty, that's what my diameter is. Actually, you know what? I changed my mind. We're going to change the question. Don't write any of that down. Just because the answer will be real boring if it's in square feet. So ignore that. We're going to put it in inches squared. Cool. Alright, one last step for us to do anyway. So the diameter is the distance across, and that is 24. I want to know the area. First off, the area equals pi times r squared. You'll notice the formula uses r, I know the diameter. So if the diameter is 24, the radius is half of that. So 24 divided by 2. So my radius would be 12 inches. So I'm going to take that 12 inches and I'm going to put it into my formula here. So area equals pi times 12 squared. All right, I'm going to do this in steps. All right, if you do this stepwise like I'm going to do, you're going to be safer. Sometimes, depending on which calculator you're using, it isn't as smart as you are. If you're using my calculators in the classroom, then you'll be okay. You could type this in just as you see it, and you'd be good. However, if you're using, for instance, your iPhone calculator, sometimes things go a little bit wonky. So do the 12 squared part first. So pi times 12 squared. So 12 squared should give us 144. So 12, I don't have a squared button, so I'll show you a couple different ways to do it. You could do 12 times 12. So that's the same as 12 squared. Or, this little x to the y button brings up the exponent. 12 squared. Also 144. So pi times 144. Right, now we're going to times that by pi. And there's my area. 452. We're going to do 2 decimal spots, so that'll be 0.39. So that was 452.39. 52.39 inches squared. Right. Just as a side note, another way to do exponents. So if you wanted to type in 12 squared, you could type in, depending on what calculator you're using, you could use this button here. That is the exponent button. So you could say 12 to the power of 2. And that'll still give you 144. Okay, that's another way to do exponents. Alrighty. Let's do some more examples. A circular punch bowl has a radius of 15 centimeters. If the bowl is filled right to the brim, what area of the punch is exposed to the air? So what that's asking for is if you have a circle, and yes, that is a perfect circle, and the radius, so the halfway, is 15 centimeters, we want to know the area. So the area is pi times r squared. This one's nice. You can just put the radius straight into your formula. Pi times 15 squared. So I go to this, my calculator here. I'm going to do this, I'm going to type it straight in this time. Pi times 15 squared. You can do that. Bam, there's my answer. 706. What am I rounding to? Nearest square centimeter. So it'll be 706.8. I'm rounding up, so 707. My area is 707 centimeters squared. Easy peasy. All right, let's get on to some of the fun ones. Composite shapes. All right. The following is a plan for a backyard ice rink. The ends are semicircles. What is the area of the rink to the nearest square foot? All right, so you'll notice, let's just get that out of there, that I've got my two semicircles and a rectangle in the middle. Now, if you do a little bit of rearranging here, I take my two semicircles and put them together, I have what's supposed to be a full circle. So I've got a full circle and a rectangle. So the area of my hockey rink, so I'm just going to draw a little hockey rink here, is equal to the area of the circle plus the area of the rectangle. Let's do the easy shape first. Let's do the rectangle. So the area of the rectangle is just length times width. Length was 20, width was 10. So that area, I'm not even going to a calculator, 20 times 10 is 200. Alrighty. Save that for later. Now let's do the area of the circle. That is pi times the radius squared. So looking at this, I don't know what the radius is, but remember this side matched up with this side. So this side here is 10 feet. So my radius is half that. So half of 10 would be 5 feet. So there's my radius. So the area of the circle is pi times the radius squared. 5 squared. So pi times the radius, which was 5 squared, is 78.5. 0.5, and that's in feet squared, but I'll bring that back in a second. So now, to do my combined area, so the area of the hockey rink is my area of the circle, which was 78.5, plus the area of the rectangle, which was 200. And that's going to give me 278.5. And because all my measurements were in feet, my answer is in square feet. That is it. Oh, sorry, it was to the nearest square foot, so I got to round that up. So my answer, my area is 279. You ready? One more, promise, that's it. All right, Bernie is preparing for a costume party. She has to cut a circle that is 16 centimeters in diameter out of a trapezoid piece of cloth. Determine the area of the remaining cloth. It's a tricky one. Well, not tricky. Not hard work, just long work. So the area, the shapes we're using, I'm trying to figure out the area of the trapezoid with the hole missing. So first I'm going to figure out, well, what's the area of just that trapezoid? And then I'm going to subtract the area of that circle hole. Good enough. So the area of a trapezoid, just leave that for later, of the trapezoid was 0.5 times A plus B times the height. So remember when we were labeling a trapezoid, A and B were the sides parallel to each other, so we'll call this A, call this B, and the height was the distance between them. There we go. So let's just sub those numbers in. So my area is 0.5 times 25 plus 40. Remember your brackets, they're super important. Times our height, which is 30. I'm going to do my brackets first. So 0.5 times 25 plus 40 is 65. Now times 30. Right, now I can jump that into my calculator. Right. The more steps I do, the less chance of making a mistake. So that's 0.5 times 65 times 30. 975 square centimeters. Alright, that is for the trapezoid. Alright, now let's figure out the area of the circle. Remember, the formula was pi r squared. Now, what do we know about this circle? Oh, I already have it underlined. It is 16 centimeters in diameter. So if the diameter is 16, the radius is 16 divided by 2. Cut that in half, you get 8. So the area of the circle is pi times 8 squared. Right, jump to my calculator. Pi times 8 times 8. Right, 8 squared is just 8 times 8. It is 201-ish, a little bit bigger. But since we're rounding to the nearest square centimeter, I don't feel bad. Right, so now I just have to remember that I had looking for the area of the trapezoid with the hole cut out of it. So I'm going to take the area of the trapezoid and subtract the area of the circle. The area of the trapezoid was 975. The area of the circle was 201. 975 minus 201 should give us 774, but since I've made a mistake in the last video, or one of the last videos, I'm going to double check. So that was 975 minus 201. 774. 774, yes! Alright, and that's in centimeters squared. Alright, so I know I went through that kind of quick. If you have questions, ask me. Work on the practice questions, have fun, work on those assignments. Let me know when you're ready for the test.